Okay, this is our memory device, and we're going to use this for the next several days. You guys really need to focus today. Today and tomorrow are going to be a little bit more confusing. We'll start off kind of easy, and then we gradually get a little harder. This is a memory device. We say it SohCahToa. This is what sine is defined to be. Sine is defined to be opposite over hypotenuse. That's a memory device. Sine is opposite over hypotenuse. That's what it says here. Cosine is adjacent over hypotenuse. So that's what this means. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent, so that's what this means. Tangent is opposite over adjacent. We talked about what's opposite, what's adjacent, what's the hypotenuse. So we're going to come down here and we're going to try some of these. We're working with these triangles up above. We don't even have any numbers, so these should be pretty easy. I'm going to go ahead and write down the memory device so we kind of have it right in front of our face. SohCahToa. And once again, I'm just going to go through it. It means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so sine, according to this, is what over what? Opposite over hypotenuse. And I can get that just by looking right here at my memory device. Sine is opposite over hypotenuse. And it wants to know sine of angle A. So we already labeled our triangle when we were working with angle A. And what did we say was the opposite side? Which of these is the opposite side? The opposite side is little a. So I'm going to put little a. And then the hypotenuse. Which one did we label the hypotenuse? Little c. So I don't even have to think about what's opposite, what's hypotenuse, what's adjacent. We already labeled it yesterday. Okay, let's look at our memory device. Cosine is what over what? Adjacent over hypotenuse. So let's look it up at our picture. Which one did we label as adjacent? Little b. So that would be the adjacent side. And which one did we label as hypotenuse? Little c. And that would be the cosine of angle A. Okay, looking at our memory device, tangent is what over what? Opposite over adjacent. Okay, so go up and look at your little picture. And what did we say was opposite? Little a. And what did we say was adjacent? Little b. And that would be the tangent of angle A. Okay, and then these next ones are about angle B. And so that's why we went and we talked about what the scenario is if angle B is the one we're interested in, where this one is all the way across from it, so that's why it's opposite. This one's right next to it, so that's why it's adjacent. This one's the hypotenuse because it's across from the right angle. Okay, so sine is what over what? Look at the memory device. Sine is what over what? Opposite over hypotenuse. Let's go down the list. Cosine is what over what? Adjacent over hypotenuse. And tangent is what over what? Opposite over adjacent. Okay, so I want to see if you can look up at your picture when we were working with angle B and fill in what these are. And then I'm going to draw 3 sticks. So look at your picture here that we already labeled and write down the rest of that. Not here. Oh, Christian's still gone. Cody. Okay, Ariana, you're my first one. What'd you get for sine of B? B over C. Does anybody need to explain? Okay. Logan, how about cosine? A over C. Very nice. And tangent goes to Cody. And what'd you get for tangent? The tangent?
I don't know.
Well, then I'll help you. It wants opposite. Which one did we label as opposite?
B.
Little b. And then it wants adjacent. And which one did we label as adjacent?
A.
Little a. And there it is. So this was really just trying to get you to know what they're defined to be. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So now let's do one where we actually have numbers and have to do a little bit more. So let's flip the page. Okay. First thing we want to do is locate that hypotenuse. Where is the hypotenuse? 10. Whatever's across from the right angle, that's the hypotenuse. So I suggest always labeling the hypotenuse first. Then we're going to go to where they tell us. If they're telling us to find sine of S, cosine of S, tangent of S, they want me to come over here to angle S. So when I come to angle S, I need to figure out what the 8 is and what the 6 is. Which one is the opposite side? 6. 6 is opposite angle S because it's all the way across from it. So the side 6 is the opposite side. And the 8's right next to it, so the 8 would be adjacent. So every time you see a picture, label hypotenuse first, then go to the angle that they're interested in and label which one's opposite and which one's adjacent. Okay, let me go ahead and write my memory device down in front of me. So SohCahToa. Is this new to everybody?
Yeah.
Okay, I figured it was. Okay, so if I want to find sine of S, I need to know it's what over what. According to the memory device, sine is what over what? Opposite over hypotenuse. Now I just have to look at my picture. How would I write opposite over hypotenuse? 6 over 10, and then I can actually reduce that to how much? 3/5. So that's the sine of angle S. Okay, next I'm going to find cosine of angle S. So I need to know what cosine is defined as. And cosine is defined as what over what? Adjacent over hypotenuse. So now all I have to do is look at my picture. And what would I write for adjacent over hypotenuse? 8 over 10. And then I can actually reduce that to 4/5. Okay, and then the last one it wants me to find is tangent of angle S. So looking up at my memory device, tangent is what over what?
Opposite over adjacent.
Opposite over adjacent. Now I just need to look at my picture, and how would I write opposite over adjacent? 6 over 8, and that reduces to how much? 3/4. Okay. And we need to be able to know how to do this for everything else that I'm going to teach today and tomorrow. You feel okay with that? Okay, this next picture is going to be different. If you notice this picture that we were working with, they gave us all 3 sides. Look at this next picture. Did they give us all 3 sides? We need to figure out all 3 sides before I can actually do what they want me to do. So this is reviewing what we've already learned. This is a 30, 60, 90 triangle, and some of you still need a little practice with this, so hopefully the more we do it, the better you get. What do I label across from the 30? Do you remember? An X. Every time across from the 30, I label with an X. Okay, now let's go across from the 60. What do you label across from the 60? X square root of 3. And what do we label across from the 90? 2x. Okay. Once you're done labeling, you need to know what x is. Do I know what x is? X is 6. So this is an easy one. If x is 6, I would put a 6 in this x right here. And what would 2 times 6 give me? Okay, so that side's 12. And if x is 6, what would this side right here be? 6 square root of 3. Okay, now that I know all 3 sides, I'm going to start labeling. So let's start with the hypotenuse. Which one's the hypotenuse?
12.
The 12. Whatever's across from the right angle, that's your hypotenuse. Now let's look at what angle they want me to work with. They're asking me to find sine, cosine, and tangent of angle C. So I'm going to come over here to angle C. And once I'm at angle C, I need to figure out which one's opposite and which one's adjacent. Which one would you say is opposite? The 6. The 6 is all the way across from angle C, so that's the opposite. And then the adjacent would be the 6 square root of 3 because it's just right next to it. Now we're ready to go. So you have to make sure you know all 3 sides to your triangle, and then you have to make sure you have them marked, opposite, hypotenuse, adjacent. Okay, first one up is sine of angle C. So if you have to look up above, sine is defined as what over what? Opposite over hypotenuse. Now let's look at our picture. How would I write opposite over hypotenuse? 6 over 12, and then I can reduce that to give me 1/2. There we go. And that's sine of angle C. Okay, now I want to find cosine of angle C. Cosine is defined as what over what? Good. Adjacent over hypotenuse. So let's look at our picture. How would you write adjacent over hypotenuse?
6 root of 3 over
Good. 6 square root of 3 over 12. But I could actually reduce that to square root of 3 over 2. Or 1 square root of 3 over 2. All I did was I reduced 6 over 12. 6 over 12 reduces to 1/2. I just don't have to put that 1 there. I can, but I don't have to. Very nice. Okay, now let's try tangent. So tangent of angle C is defined as what over what? Opposite over adjacent. So look at our picture, and how would we write opposite over adjacent? Good. 6 over 6 square root of 3. That can reduce. What would that make?
1 square root of 3.
Not quite. No. I will have to. These can just cross out, right? 6 divided by 6 is 1. Where's that square root of 3 at? It's at the bottom, so he's still there in the bottom. Now, if nothing else is up top, we got to put the 1 there. But I do need a fufu. I do need to rationalize this denominator. And what would you multiply by? And if I multiply by square root of 3 over square root of 3, what would that final answer be? Square root of 3 over 3. And that would be the answer to tangent of angle C. I can't reduce it to get a 1 because this one's under a square root and this one's not, so we're done right there. So remember, we can't leave square roots in the denominator, so we have to rationalize the denominator. We have to do the fufu. Okay, looking at this next picture. When I divide 6 by 6, 6 divided by 6 is 1. And so that's where really the 1 comes from. And then the square root of 3 was in the bottom, so it's still in the bottom. And then I have to get it out of the bottom. Okay, looking at the bottom picture. Do I know all 3 sides? Nope. I need to find this guy right here. Do I know if this is a 30, 60, 90 or a 45, 45, 90 triangle? No, so, right, I'm going to have to do Pythagorean theorem. A squared plus B squared equals C squared. What would it look like, my equation? 4 squared plus 10 squared equals X squared. Okay, what do I get if I add 4 squared plus 10 squared? 116. And then I can't keep the squared, so I need to square root both sides. And I want to practice putting this in simplest radical form. Can somebody find a perfect square that goes into 116? The largest one? Yeah. When you try the very first one on the list, 4, you get 29 goes in there, and 29 can't be divided by any of those perfect squares, so I know that's got to be the biggest. So 4 goes in there 29 times. And then what is the square root of 4? 2. You can't take the square root of 29, so that just stays square root of 29. Okay, so I now know this side is 2 square root of 29. So we're practicing our 30, 60, 90 skills, our Pythagorean theorem skills, so that hasn't gone away yet. Okay, so now I want to start labeling. Do I have the hypotenuse? Which one is it? 2 square root of 29. That's our hypotenuse. Okay, now let's look at what they're asking about. They're talking about sine, cosine, and tangent of angle Z. So angle Z is the angle I want to go to. So now, what would you label the 4? Adjacent. It's just right next to it. So the 4 is adjacent. And what would you label the 10? Opposite, because it's all the way across from angle Z. So 10 is the opposite. So once you have your 3 sides and you've marked them with opposite, adjacent, and hypotenuse, you're ready to begin. Okay, first one up is sine of angle Z. Sine is defined as what over what? Opposite over hypotenuse. And how would I write opposite over hypotenuse? 10 over 2 square root of 29. Now I can actually reduce that. What would that reduce to be? Not 5 square root of 29. 5 over square root of 29. But then I can't leave that square root of 29 in the denominator, so I'm going to multiply by my fancy form of 1, which is square root of 29 over square root of 29. And what would that final answer be? Yeah. Are you getting to where you can do that in your head? Okay. So if you don't want to show me multiply by square root of 29 over square root of 29, if you can just go straight to the answer, that's fine by me. Okay, next one up is cosine. So cosine of angle Z. Cosine is defined as what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. And if I look at my picture, what would I write for adjacent over hypotenuse? 4 over 2 square root of 29. Okay, I want to see if you guys can reduce and simplify from here, and then I'm going to draw a stick. So see if you can reduce and simplify. Okay, Joel. What do you think?
I'm not done yet.
Okay.
Two square root 29 over 29.
Yes. 4 over 2 reduces to 2. So I get 2 over square root of 29. And then if I do my FFU, my square root of 29 over square root of 29, which you don't have to show me that work if you don't want to, you get 2 square root of 29 over 29. Okay. And then the last one wanted tangent of angle Z. And tangent is defined as what over what? Opposite over adjacent. Okay, so take a moment, look at your picture, see if you guys can do it. Opposite over adjacent, then I'll draw another stick. Opposite over adjacent. Okay, Andrea, what'd you get?
10 over 4.
10 over 4, and then you can reduce it.
5 over 2.
5 over 2. Very nice. Okay, how are you feeling so far? Are you okay? Okay, we did have to practice some stuff, the 30, 60, 90s, Pythagorean theorem, that are still a little bit of a pain. Okay, we're going to have 2 parts to assignments tonight. So let's flip to this page. This was the one behind the one where you labeled opposite, hypotenuse, and adjacent. And I'm going to get you started with it. And then we're going to move on and do some others. Okay, first of all, this first picture you can't see. So this is supposed to be an R down here. It's supposed to be a P up here. This left side is supposed to be a 3. And the hypotenuse is supposed to be a 5. This is supposed to be a 3, 4, 5 triangle. Okay. Because 3 of the problems are talking about angle P, And 3 of the problems are talking about angle Q. I'm not going to actually label my triangle like I normally would, but I am going to label the hypotenuse because the hypotenuse is always the hypotenuse. So which one's the hypotenuse? The 5. Okay. Opposite and adjacent, those depend on what angle you're at. So let's just look at number 1. Sine is defined as what over what? Opposite over hypotenuse. Do I need to write the memory device down? SohCahToa. Okay, so this one wants sine of angle P. So if I came up here to angle P, up here, what side would be opposite? 4. So it would be 4 over hypotenuse, so 4 over 5. And then I can't reduce that, so I'm done. Okay, let's go down to number 5. Number 5 is wanting cosine. Cosine is defined as what over what? A over h, adjacent over hypotenuse. But this time, number 5 is talking about angle Q. So if I come over here to angle Q, which one's the adjacent? The 4 is the adjacent, because the 4 is the one right next to it. So it'd be 4 over 5. Okay, I want to see if you can do the 2, 3, 4, and 6. And then I'm going to draw 4 sticks. Ooh, that kind of rhymes. Do 2, 3, 4, and 6, and then I'll draw 4 sticks. 2, 3, 4, and 6. And then we'll talk about the other ones here in a second. 2, 3, 4, and 6.
This tells you sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Yes. Yeah, there's just a little memory device for that. Oh.
Okay. You think you're ready? Not done yet? Uh-huh. Oh, no. As long as you can keep it improper. As long as they can't be reduced, like you can't divide them both by the same number, you can leave it improper. That's okay. Okay. All right. Carly, you're my first one. What did you put for number 2? 3 over 5. Cosine is adjacent over hypotenuse, so it's 3 over 5. Does anybody need me to explain? You sure? Okay. Kaylin, what did you put for number 3? 4 thirds. 4 over 3. Tangent is opposite over adjacent, so if I go to angle P, I look for opposite and adjacent, and it's 4 over 3. Good. Okay, number 4. Zach, how about that one? Three over 5. Very nice. Opposite over hypotenuse, so 3 over 5. Does anybody need me to explain? And Jada, 6. 3/4. 3 over 4. part of this is going to be your assignment, and then I'm going to give you more. But before I give it to you, do you notice how we don't have all three sides? Let's just go ahead and find all three sides and get that done. So this guy right here, what kind of triangle does it look like we're working with? 45, 45, 90. So let's go ahead and figure out our sides. Across from the 45, we label with X. So across from the 45s, we label with X. And across from the 90, do you remember? X squared root of 2. Okay, so I need to know what X is. Do I know what X is? X is 5. So what would this side right here be? 5. And what would this side right here be? 5 squared root of 2. Okay, now that you know your three sides, you should be able to do it. You may have to do some foo-fooing, though. Okay, let's look at the next picture. In this picture, do you know if it's a 30, 60, 90 or a 45, 45, 90? Okay, so what am I going to do to find that missing side? Pythagorean theorem. So what would it look like? What squared plus what squared equals what squared?
7 squared plus x squared.
Good. 7 squared plus x squared equals 25 squared. Okay, if I want to get x squared by itself, I'm going to move the 7 squared by subtracting it. I don't want to show that work. What would you get if you subtracted 7 squared from 25 squared? 576. Okay. Let me just see if you can take the square root of 576 and get something pretty. So square root of 576, and it makes a pretty little 24. So I know that this missing side up here is a 24. So now that you know all three sides, you should be able to do the rest of those. Okay, before I go to the next page, I want to make sure that everybody knows how to put stuff in like this, because we're going to do that in the next couple pages. So your calculators have probably already been fixed, but if they haven't, I want to show you how to do it. These are all in degrees. We're talking about triangles and their degrees inside. So we need to make sure our calculator is in degrees. Do you guys see the button that says mode? It's to the right of the blue second. So let's hit that button that says mode. And we need to make sure that degree is highlighted. A lot of your calculators probably already are, because my first period is a really big class and they probably already did it for you. But if radian is highlighted, you need to arrow down, arrow over, and hit enter so degree is highlighted. Does everybody have degree highlighted? Was that a yep or a no? Okay, now to quit the screen, do you all see how quit is in blue above the word mode? So I can just go second mode. If I go second mode, I can quit right out of that screen. Okay, so I just want to practice finding sine, cosine, and tangent. Do you guys see them in your calculator, sine, cosine, and tangent? Yeah, they're right here. Sine, cosine, tangent. Okay, so if I wanted to put in sine of 72, I just hit the sine button and then the 72. Let's practice rounding to the nearest thousandth, because that's what this page says to do. What would you get if you rounded that to the nearest thousandth? Not 5.951. Just one. That's the tenths, that's the hundredths, that's a thousandth. Yes, there is a 5 in it. Good job. Okay, cosine of 27, I hit the cosine button, and then the 27. And what would you get if you rounded that to the nearest thousandths?
4, 5, 4. Are you 5, 8, 9, what?
I think you must have put something in wrong. Did you hit the cosine?
Awkward.
It's okay. And then tangent, I did hit the button that says tangent, and then tangent is 64. And then if I do that, I get 2.050. Okay. Okay, so in the next thing I'm about to show you, we're going to be plugging things into the calculator like that. Okay, so far, for homework tonight, you have these two columns to finish up. That shouldn't take too much time. Now let's flip the page. Okay, you have a test coming up on Monday. I'm going to give you the review tomorrow, I believe. And I've already started working on the video for the review. My goal is hopefully on Friday you guys can have some class time to work on the review in class, and I can try to answer some questions. And then you'll have the whole weekend to watch my review videos. Hopefully you do that, okay? Because like when we have problems like this, I go through them step by step. So the video should be pretty helpful, and you'll have the weekend to watch it. So Monday will be a test. So the thing about the test on Monday is you'll see a picture like this, and you have to decide, is it a 30, 60, 90? Is it a 45, 45, 90? Is it a Pythagorean theorem, or is it going to be a trig problem? That's SohCahToa, that's trigonometry, trig. So looking at this picture, is this a 30, 60, 90?
No.
45, 45, 90?
No.
No. And I can't do Pythagorean theorem because to do Pythagorean theorem, I have to know two sides. So this is going to be a trig problem. So the first thing I want to do is locate the hypotenuse. Which one's the hypotenuse?
8.
The 8. And then I'm going to go to the angle that I actually, oh, Mr. Blue Marker, this is a sad day for you. Well, sometimes it comes back to life, so I'm just going to cap it for a little bit. We'll see. Okay, after I label the hypotenuse, I go to the angle they give me in the triangle, the angle other than the 90, and then I need to label the x. Would the x be opposite or would the x be adjacent?
Opposite.
X would be opposite. Okay, so now let me write our memory device up at the top. SohCahToa. This tells me what to do, for the most part. Which one uses an O and an H? This sign. Sign uses the O and the H. So I'm going to use sine. And so the way these go, we're going to write an equation. It's going to be sine, because that's the one that uses the O and the H. It's always sine of the angle, or cosine of the angle, or tangent of the angle. And the angle is 65. And then sine is defined as opposite over hypotenuse. How can I write opposite over hypotenuse? X over 8. Okay, so now my mission is to solve for x. If I want to get x by itself, I need to get rid of division of 8. How do I get rid of division of 8? I multiply by 8, which would be the reciprocal, 8 over 1. And if I multiply the right side by 8, I have to multiply the left side by 8. And then these 8s are just going to cancel out, leaving x. And in my calculator, I'm just going to type that in. So, try it. In your calculator, put in 8 times sine of 65. And this time, let's round to the nearest tenths. So, in our calculator, 8 times sine of 65, and I'm going to round to the nearest tenths. And what would you say? 7.3. Did everybody get it? Okay, so our first 3 problems are all different from one another. So the first 3 that we look at today, we're going to solve them a little bit differently. But I have to decide what kind of triangle it is and what I'm going to use. This next picture, I don't know my angle. If you ever are trying to find an angle in the triangle, we'll always use trig. Sine, cosine, tangent. So if you're ever looking for an angle, we'll always use sine, cosine, or tangent. So first of all, do I have a hypotenuse in the picture? Which one? 5. 5's the hypotenuse because it's across from the right angle. Okay, then when I go to the angle in the triangle, what would I label the 3? Adjacent. Okay, which one uses an A and an H? Cosine. So I'm going to write cosine, and then it's always cosine of the angle. This time I just don't know what the angle is, so I'm going to write that down, and this is pronounced theta. It's a Greek symbol, T-H-E-T-A, theta. So it's cosine of theta, and then cosine is defined as adjacent over hypotenuse. How would I write adjacent over hypotenuse? 3 over 5. Okay, now this is just going to be weird, so you're just going to have to listen, and this is how you're always going to do it. If I want to get theta by itself, which is what I want to find, I need to get rid of cosine. To get rid of cosine, I'm going to do what's called the inverse of cosine. So theta will equal cosine to the little negative 1. That means inverse of cosine, and then I just recopy 3 over 5. So write that down, and then I'll talk some more. I am going to do this every time I'm trying to find an angle. Every time I'm trying to find an angle in the triangle, I will do this. So if I'm trying to get rid of cosine, I'll do inverse cosine. If this was a tangent, this would say tangent to the negative 1. If this was sine, this would say sine to the negative 1. Do you see this on your calculator somewhere?
Yeah.
It's above cosine, right? So how would I get to it? Second cosine. All right, so let's do that. So I go second cosine, and then after I put in second cosine, I put in 3 divided by 5. So second cosine, 3 divided by 5, and that gives me, rounded to the nearest tenths, what would you say? 53.1. And that's degrees because we were finding an angle. So every time you're trying to find an angle, you're going to do this inverse. Cosine to the -1, or sine to the -1, or tangent to the -1. Okay, we're going to work till the bell, so let's keep going. No huns. Yeah, you'll have homework over this too, but I won't make you use the calculator unless you have one. So I'll show you what you can do. Okay, looking at example 3, this is another one. It's going to solve a little differently than the last. Okay, first thing I want to do is, I notice it's not a 30, 60, 90 or a 45, 45, 90. I can't do Pythagorean theorem because I don't know 2 of the sides, so it's trig time. Do I have a hypotenuse in this picture? Which one? Okay, so I'm going to label that my H. Then I come to my angle that's in the triangle, and what would you label the 3? A, adjacent. Okay, so SohCahToa is the memory device. Which one uses the A and the H? Cosine. So it goes cosine of the angle. The angle's 42. And cosine is adjacent over hypotenuse. So I would put what over what? 3 over x. Okay, this one's different than the first one because x is in the denominator. So I need to pop this x out of the denominator. So to get rid of division of x, I'm going to multiply by x. So I'm going to multiply both sides by x because I can't have that x in the denominator. These x's are going to cross out, leaving that 3 there. And then the left side, I'm just going to recopy it. X times cosine of 42. Okay, at this point, if I want to get x by itself, do you know how I could make that cosine of 42 go away? The only time we're going to do inverse is if I'm trying to find an angle. I divide. Since those are smushed together, since they're multiplied, I'm going to divide. So I divide by cosine of 42. And now it's calculator time. So in my calculator, I just would put in 3 divided by cosine of 42. So let's try that. 3 divided by cosine of 42. And did you get something that looked like that? So it's about 4.0 if I round to the nearest tenths. Okay, let's look at number 4. So you've seen the 3 kinds of problems. Those are the only 3. So now it's just a matter of practicing. Okay, looking at example 4, do I have a hypotenuse in this picture? No. So I'm going to come to the angle they gave me, which is theta. What would you label the 15? Adjacent. What would you label the 8? Opposite. Which one uses the O and the A? Tangent. So it goes tangent of the angle, and what's the angle? This little theta. Tangent is defined as opposite over adjacent, so how would I write opposite over adjacent? 8 over 15. Okay, this is when you do the inverse. If you're ever trying to find an angle, you're going to do the inverse. So this time I do the inverse of tangent. So it's tangent, little -1, 8 over 15. So whenever you're trying to find an angle, that's when you do the inverse. So if it's tangent, it's inverse tangent. If it's sine, it's inverse sine. Okay, do you see that little guy in your calculator? I go second tangent. Second tangent has it. I put in 8 divided by 15. And what would you get if you rounded to the nearest tenth? 28.1. Okay, so what I want you to try to do is this next page. But you could stop right here. You wouldn't have to give me your final answer. So I want you to try these 8. Okay, you don't have to give me an answer, but I need you to show the equation and how you would solve it. And then we'll practice, we'll go over these tomorrow.